All right, so our last big topic for the semester is vectors. Vectors is a little bit different than things that we've been talking about before, but that's pretty great. So what's a vector? Well, a vector is something that has both a magnitude and a direction. So what does that mean? Well, we understand a magnitude is something like a link, okay? So for example, oftentimes we think about vectors when we're giving directions. So I could tell you, say walk 10 feet, but walk 10 feet in which direction? Should I walk 10 feet south? Should I walk 10 feet north? Should I walk 10 feet southeast? Okay, telling someone walk 10 feet southeast is giving information in terms of a vector. You're telling them a magnitude or a distance to walk 10 feet, but you're also giving them a direction, southeast, okay? So a vector is a quantity or a thing. So a vector is a quantity or a thing that has both magnitude and direction. Okay. So something like 10 feet southeast has both magnitude and a direction. Okay. Now we are going to be representing vectors in two-dimensional space. Okay. So one way I can do that is to just draw a line. Okay. So here's a vector. Now it has a length or a magnitude, but it also has a direction. That little arrow tells me which way this vector is going. Okay. And notice that that vector is slightly different than this vector, which has both a different length. This guy is shorter than this guy, so these are two different magnitudes, but they also have a different direction. Okay. So one thing that we're going to think about is, to start with, I just want to introduce some of the vocabulary of vectors. Okay. A vector has an initial point, that's this guy here, and a terminal point, that's this guy up here. Okay. And in general, we're going to talk about vectors. So we can talk about vectors in a couple of different ways. I've named this vector V, and I've used kind of the vector symbol as a superscript. Okay. You also can see vectors described using bold letters. Okay. Your book often uses bold letters to describe them. It means my math lab is going to use bold letters to describe them. We can also describe vectors by talking about their initial point. So if I call this point O and this point P, then I can describe this as the vector OP. And again, I would use bold letters to do that, or I would indicate that with a vector symbol over the top. Okay. When we talk about the magnitude of a vector, that's the length of a vector. And we're going to use things that look like absolute value symbols to signify the magnitude. So the magnitude of the length of vector V would be this. The magnitude or length of vector OP would be shown by that. Okay. Now, in order for two vectors to be equal, they need to not only be going in the same direction, but they also need to have the same magnitude. Okay. So vectors are things that have both magnitude and direction. Okay. And it seems kind of weird to talk about them just with this sort of description here. So we're going to talk about how we represent vectors both geometrically and algebraically. Okay? And in order to do that, we're going to start by looking at a Cartesian coordinate system. It's often useful for us to think about representing vectors on a Cartesian coordinate system, because it makes it a little bit easier for me to think about their magnitude and their direction. Okay, so put some points on here. I could think about having a vector that has an initial point here at 0, 0, and an ending point, say here at, we'll go 1, 1, 2, 3. So again, this vector has its initial point at 0, 0, and it has its end point at 1, 3. Okay, and it's fairly easy for me to see that vector. Now, I can also think about having a vector in a different position that is the same as this vector. Okay, so let me sketch something. So I'm going to make the claim that those two vectors, the purple vector and the blue vector, are actually the same vector, even though they're at different locations. Now, how can I make that claim? Well, I can make that claim because remember, for a vector to be equal, the vector has to have the same magnitude or the same length and the same direction. Okay? Well, we're going to get into this more formally using things like angles and length or distance formula. But really, if I look at this, right, this guy starts here and goes up 1, 2, 3, and over 1. This guy starts here and goes up 1, 2, 3, and over 1. So these represent the exact same thing. In other words, if I could peel this vector up and move it and set it down right on top of this vector, they would be exactly the same. So where a vector is in the space doesn't matter. What matters is its length and the direction that it's pointing. All right. So I've mentioned this, but two vectors are equal if they have the same magnitude and the same direction. That doesn't mean that they have to have the same position. In other words, they don't have to occupy the same space. We sort of saw that on our Cartesian coordinate example. But as long as they're the same magnitude or the same length and the same direction, okay, so those two vectors, the blue vector and the red vector, would be equal to each other because they go the same direction and they're the same length. Okay? We also think about having sort of opposite vectors. So an opposite vector would be the same length, but it goes the opposite direction. So notice, I realize these are a little bit small. So notice my blue vector goes this direction, my purple vector goes this direction. So these are the same magnitude, but opposite directions. We often think of these, if I name this the vector v, so if my purple vector is the vector v, I can think of blue as negative v, okay? These have the same magnitude, but they're opposite in direction. That's going to be important for us as we move forward, thinking about how we add these, subtract these, or scale these things, okay? All right, so we've got vector as a magnitude and direction. Vectors are equal when they're the same magnitude and the same direction. And then we have opposite vectors, which are the same magnitude, but go in opposite directions, okay? What we're gonna do now is look at all of the different ways that we can work with vectors. We're gonna learn to add and subtract vectors. We're gonna do that both algebraically and geometrically. We're going to think about breaking up vectors into their component parts. So that is, I'm going to be able to think of a vector as a horizontal component and a vertical component. And that's not that weird as a little preview, especially if we think about, again, going back to our Cartesian coordinate system. Okay. So if I have a vector that starts at 0, 0, and again ends at 1, 3, well, it makes a lot of sense for me to think about that vector in two components, a horizontal component and a vertical component. And we're going to talk about how we can label vectors using their horizontal component and their vertical component, how that can help us add vectors, how that can help us subtract vectors, and eventually how that can help us think of something called the dot product of vectors, which is also going to allow us to think about the angle between two vectors. Okay?